The idea with factoring with algae tiles is you have to make a rectangle, the smallest rectangle possible, or the most compact one, because with 4 x's we could line these up in a straight row and take 8 of these. 8. We could line it up as one long rectangle. But the idea with factoring is to say, can you take these and make the most compact rectangle possible? So if I put 4 like this, and I make my 8 like this, now if I took the time to line them up perfectly, you would say, yes, Mr. JR, that's a perfect rectangle. Right now, if those are lined up nicely, could you see that that's a rectangle? Okay. If we look at the length and the width, because that's how algae tiles work. Algae tiles are based on the idea of area. The reason the x squared tile is an x squared is because this side is x and this side is x, and the area would be x squared. An x tile has one side as 1 and one side is x. That makes an area of x. And the one tile has a side of 1 and a side of 1, making an area of 1. So it happens that the one tile matches up with the x tile here because that's both the size of 1. If we know that, we can say how long is that part of the rectangle and how long is this part of the rectangle? How long is this? X plus 2 more, right? And this side would be? Yeah, there we go, 4. So this area that is 4x plus 8 is equal to a rectangle that has a length of 4 and a width of x plus 2. If you distribute that 4 through, can you see that they're equal? 4 times x, 4 times 2 gives me 4x plus 8. Excellent. So here's another one. Do you need me to go back? You write that down. I'm going to get my algae tiles ready again. I'll need 2x squareds and 6 x's. So this side would be 2x. You okay with that? And this side over here would be x plus 3, because these sides are all 1s, right? And that's an x. So that side will be x plus 3. So we could write that 2x squared plus 6x is equal to 2x times x plus 3. Now it's going to be annoying if we're going to have to draw out algae tiles every single time we factor, so we need to start looking for what are techniques that we can go from here to here without having to make rectangles and draw a whole bunch of algae tiles. The idea is same thing with prime factorization and writing all the factors of a number. We look at the two things that we have and see what do they have in common. What are the factors that they have in common? What would divide both 2 and 6? 2 would work, right? So that's how we get this 2. What about the variables? Do they have any variables in common? This one has x times x. This one has x. They have one x in common. So I can also pull out an x. Once I do that, I say, well, if I took 2x out of here, like dividing, what would be left that I would need to multiply by to get the 2x squared? I'd need one more x. And what would be left in the 6x if I took 2x out of that? What would be left so that when I multiply, I get 6x? If we look back at our first example, can you see that that you could look at the first number, the 8 and the 4. The biggest number you could divide both of those by is a 4. And then what would be left? An x plus 2. And this is how we're going to factor when we don't have algetiles. So I'll let you copy this down. So we look at 2x cubed and 4x squared, and the biggest number you can divide both of them by is 2. And the x cubed and the x squared, they both have an x squared in there. And then we have to ask ourselves, well, what would be left if we pulled the 2x squared out of the first one? Just an x. What would be left if we pulled out a 2x squared out of the second one? Just the 2. Always when we're done, we do a quick check. If I multiply this by this and this by this, in other words, if I distribute, what do I get? Do I get what I started with? Then I know that I factored it completely. This one started off cubed. We wouldn't even be able to draw this with algetiles. A cube would be like an x squared, but actually made into a cube. And so you can't, once you get into the higher level ones, you can't do it with algetiles, because some of them you can't draw with algetiles. And you can use different letters, right? And we sort of use algetiles only for x's and x squareds. We're going to get factoring questions with y's. So we're going to have to use the algebra way. But the algetiles help us see kind of the idea of what's happening.
No, I was just wondering because like you had cube, but then when you got the answer, there was no cubes.
Well, oh yeah, if we go back to the answer, right? There's no cubes left, but when I distribute 2x squared times an x, I would get an x cubed, right? It's the opposite of distributing. It's going backwards. Sort of like dividing is the opposite of multiplying. So I get you to multiply 7 times 9. You say 63, right? I tell you 63 and ask for what are the numbers. I give you the answer and say what numbers multiply to that. Okay? Here's the answer. What numbers could have been there before to make those? And probably the most important skill in pre-calculus from grade 10 to grade 12 is factoring. We're going to do it over and over and over again. And there's so many applications. And you'll keep finding them out as you go along. Here's another place we use factoring. Here's another place where you have to factor. Now we have 3 things, so there's got to be something common in each of the 3. So look at the numbers first. Is there a number you can divide -3, 3, and -6 by? 3. Look at the variables. What variables in all of them? And only one y, right? Because the last term only has one y. So now when we put our brackets here, and we look at our first term, well, what would need to be here so when I multiply by 3y, I get -3y cubed? -1y squared. And you don't have to write the 1, you can if you want. And then here, there would have to be just a y for the second one. Because you ask yourself, well, what would have to be here? So if I multiply by 3y, I would get 3y squared. And finally, -2. Now, there's going to be sometimes you're going to do the same question where it may be advantageous because someone might say, well, they each divide by 3, but they each can also divide by -3. Because if you can divide by 3, you can divide by -3. So you can write it by taking out the 3. It would also be correct if you took out the -3 and a y. Of course, if I took out the -3, then the first one would just be positive y squared instead of negative y squared. The second term would be a negative y instead of a positive y. And finally, we would get a +2 instead of a -2. And both of those would be right. You could choose whichever one you wanted if it asked you just to factor. Do I prefer one? I like the second one because I don't like that negative with the y squared, but that's just a personal preference. Because later we're gonna see how to factor things like y squared minus y plus 2, but we don't get to that. Kind of like polynomials unit. So we do a lot of distribution and stuff like that that we've done before, but now we're working backwards. Last year in grade 9 you did the distribution. This year we factor it to work backwards. So I'm going to give you a question, give you a couple seconds, then we'll put up the answer, see how you do, then I'll give you a new one, and so on and so forth. All right, how did you do?
2BC, 3A plus 4D minus 1.
Excellent. And when you take out everything, like you see how the last term has a 2BC, you have to remember a 1 there because you've taken it out. Again, afterwards you do a quick check. If I distribute, do I get what I started with? And I need a 1 there at the end in order to get the minus 2BC.
What if I did 2b and then times by 3ac plus
4DC minus C?
like I did 3ac plus 4cd minus c?
Okay, good. So here's the question. What happens if you took out a 2b and you get 3ac plus 4cd minus c? This isn't wrong, but it's not factored completely. And sometimes we're going to do something like this, and then at this point, you still would check inside my brackets, is there anything else in common? And now I see the c. So then you could say, well, I'll take one more step and pull out the c now, and then I'll get the exact same answer. But you would lose a half a mark if you left the c not taken out because it wouldn't be factored completely. But sometimes you're going to find that it's actually easier to do partial factoring because there might be numbers inside that, ooh, I can't see the biggest number it can divide by, but I can see something. This is good. I'll show you how that might happen in this one. Did you see that the highest number you could divide by was 6?
Oh, it's the highest number, not the lowest.
So again, did someone take out 2 to begin with? Yeah. Okay. So if you took out 2, it's not wrong, but you're not done yet, right? If you took out 2, you would get this. But then if you look inside the brackets, they still have something in common that would divide. Can you see that I still could divide this by 3? And now if I take the 3 out, now when the 3 comes out, it hits the 2, and 3 times 2 is 6. And now I would get 3p cubed plus 2, and it's the same answer. If you can see the biggest number right from the beginning, it's shorter, right? But it's not wrong if you don't see the biggest number, but then you have to know to keep checking until you can't, until there's nothing left in common in the brackets. All right, how did you do?
2x plus
Well, I'll just put it up and you can check it once you're done. All right, how did you do? How many math magicians out there? Math magician. You need sweaters.
Yeah, we have a math sweater with your face on it. And be like, it would say, add me to your wardrobe.
Oh, it sounds a little creepy. Just a little bit creepy. You could take out a 3, an M, and an N. You'd be left with 1 plus 2M and N. And it wouldn't matter if you wrote MN or NM. It doesn't matter the order. Generally speaking, mathematicians will do them in alphabetical order. So at the beginning here, this is a little bit non-perfect because the N is coming before the M. And I learned in the alphabet that M comes before N because it's bigger and meaner than the N. I don't know.
I never learned what it was those three, so I was like, I just thought it was like a scrambled letter because I was yeah, really quickly whenever we did the ABC thing. I never knew what it was.
Oh, the easy part.
You can pull out a 3, 1S and 1T, leaving you with 5 minus 7ST plus 2S squared. Again, do a quick check at the end. Distribute it out and see if it's equal to what you had before. Equals 6xy, x squared y minus 2 plus 5xy 4. Three would work, but it wouldn't be the biggest and you'd have to go one more step. Because after you take out 3, you'd notice that they all still divide by 2. So you have to, when you pull out a number, once you're done, you always look now with what's left. Can I divide any of the numbers? No, because I'm down to a 1. Are there any letters in common? No, because the middle term has no letters. So then you always check to see, make sure you pulled out the biggest thing, because you might have not pulled out the biggest thing at the end. You also always check a quick multiplication through to make sure it matches what you had to start with. And you get really good at that, the sort of mental math part. Just quick check each thing. Okay, here's your homework. I'll give you guys about 10 minutes to work on that, then we are going to start the next thing